Now for our next problem, we're going to look at graphing. We want to graph three different values. First value is -4, second value is 0, and the third value is 3. To graph these, we're going to draw a number line, and on this number line, we're going to designate a particular value as 0, and notice that we're going to move to the right in order to come up with our positive values. And as we move to the left, we're going to have our negative values. Now what we've drawn is called a real number line. We're going to take the different values that we see given and we're going to designate those on our graph. The value of -4 is going to be at this point on the number line, which is 4 units to the left of 0. The value of 0 is right here as I drew it, and the value of 3 is to the right of 0, 3 units. Now let's look at ordering integer values. Insert either the symbol for is less than or the symbol for is greater than in the area between the integers to make each statement true. Our first pair is the number 6 compared to the number -7. Now, since 6 is to the right of 0 and -7 is to the left of 0, then we know that -7 would be to the left of 6 on the number line. For that reason, 6 is greater than -7. Our larger values will appear to the right of the smaller values. Part B, we have -8 and -1. -8 would be 8 units to the left of 0. -1 would be only 1 unit to the left of 0. So the value of -1 will appear to the right of the value of -8. So -8 will end up being smaller than or less than -1. Part C, we have -25 and -2. -25 would be 25 units to the left of 0. -2 would be only 2 units to the left of 0. So -2 is closer to 0 than -25. -25 is less than -2. And finally, we have the pair -14 and 0. -14 is to the left of 0 on the number line, and so it is smaller. Now here's a problem dealing with absolute value. Find the following absolute values. We have the absolute value of -8. We want to make sure we understand what absolute value is giving us in a format where we think about the number line. If here's a number line and there's 0, we would know that -8 would be to the left of 0. The absolute value can be thought of as having as a physical concept the distance that the value is from 0. Distance would be a positive number, so we're going to end up 8 units to the left of 0, and we would say the absolute value of -8 equals 8. Let's look at the absolute value of 6. Again, if we use a number line, we can draw our value for 0. We know that 6 would be to the right of that, and as we move to the right, we would have to go 6 units. So the distance would equal 6. And so the absolute value of 6 is equal to 6. Now let's look at a problem where we're going to consider subtraction of integer values. We want to subtract, first of all, 30 minus a -7. We're going to look at this as changing the subtraction into addition of the negative. So we'll have 30 plus, we'll take the opposite of -7, and that will give us 30 plus +7, which equals 37. Our second example, we have -14 minus a -10. That will be -14 plus the opposite of -10. That's going to be -14 plus 10. And here we subtract the absolute values, which would give us 4, and take the sign of the larger, so we're going to have -4 as our result. Next, we're going to have -14. We're going to add the opposite of 10, and that's going to give us -24. Since both of these have the same sign, we add their absolute values and then take the common sign. Now let's see how to use a bar graph in a problem dealing with subtraction of integers. Use the bar graph to find the difference between the 2004 deficit and the 2005 deficit. You'll see this chart in your textbook. What we'll be looking at here would be the last two bars. We want to have the 2004 deficit, which is given to us as negative $412, and then we have the 2005 deficit, which is given to us as negative $427. Now, what we're trying to do is to find the difference between these two. The word difference makes us think of subtraction. So we're going to use negative 412. We're going to subtract from that a negative 427. To subtract, we're going to change this into an addition of the negative of negative 427. The negative of negative 427 is a positive 427. And now this can be thought of as simply a positive 427 minus 412. The difference between those is a value of 15. And so in answer to the question, there would be a $15 difference between those two given values. Now here's a problem where we'll work with integer values and exponential notation. We want to evaluate a number of different expressions. Let's start with part A. We have in parentheses the value negative 5, and we're being asked to square that. Because this is in parentheses, it tells us that we're taking the expression inside the parentheses and multiplying it times itself. So this is equal to negative 5 multiplied times negative 5. A negative multiplied times a negative is a positive. 5 times 5 is 25. Part B. This looks very similar, but it turns out that because the negatives is outside of any set of parentheses, the squaring does not apply to the negative. In other words, this is the negative of 5 times 5. That is going to equal negative 25. Part C, we have negative 4 inside parentheses cubed. That's going to give us negative 4 multiplied times negative 4 multiplied times negative 4. Now, we have a couple of ways to evaluate this. We can multiply negative 4 times negative 4. That would give us a positive 16. Then multiply that times a negative 4 to give us a negative 64. An alternative is to figure out what the sign's going to be first. We have a negative, and a negative. That's going to be 3 negative signs in a row, which ends up giving us a negative value. And then we have 4 times 4 times 4, which is going to give us our value of 64. Either way, the answer is negative 64. What about negative 3 to the 4th power? This is going to equal negative 3 multiplied times negative 3 times negative 3 times negative 3. In a similar manner, we could first decide whether the result, the product, should be positive or negative. We can do that by noting that if we have a negative times a negative, that's positive, times a negative is negative, times another negative is positive. Notice we have 1, 2, 3, 4 negative signs. Our product is going to be a positive value. We then just need to multiply 3 times 3 times 3 times 3, or 3 to the 4th, which is going to be a positive 81. Now here's a problem dealing with order of operations. Let's simplify 7 squared minus 48 divided by 4 squared times 5 plus 2. Well, let's recall that we're going to use the idea that we're going to perform exponent powers first. So we have 7 squared, which can be evaluated as 49, minus we have 48 divided by 4 squared would be 16. We're multiplying that times 5 and then adding 2. Now we have choices between doing subtraction, division, multiplication, or addition. We know that we're going to perform multiplication and division next, only we're going to do it in the order in which it's listed. So we're going to bring our 49 down and our subtraction. We'll perform the division of 48 by 16 first. That will give us a value of 3. And I'm going to rewrite the rest of the problem. Now we have a subtraction, a multiplication, and an addition. By order of operations, we know to do the multiplication prior to doing either of the other two operations. Now notice here that we're going to pick up this number as being a positive 3. That's going to be a 3 times 5 to give us 49 minus 15 plus 2. And finally, we have a subtraction and an addition. We can do those in order from left to right. 49 minus 15 is going to give us 34. And now we add 2 to give us our final result of 36. Now let's work with order of operations. Simplify negative 8 squared minus 10 minus 13 squared times negative 2. We're going to begin by applying the exponent powers. So we're going to take negative 8 multiplied times itself, which would be negative 8 times negative 8, to give us 64. We notice that we have another exponent power, but notice that we have a set of parentheses here that needs to be evaluated. So before we can apply the exponent power, we'll subtract 13 from 10. That will be negative 3 squared. In our next step now, we can apply the exponent power. 64, we're going to subtract from that negative 3 squared, which is negative 3 times negative 3, giving us a value of 9. We have now two operations, a subtraction and a multiplication. We'll perform the multiplication before we do the subtraction. That will give us 64 minus, we have 9 multiplied times negative 2, which is a negative 18. To subtract a negative number is the same as adding the positive of that value. So we're going to have 64 plus 18, which is going to give us a sum of 82.